to experiments next. Great. All right, so experiments, the biggest difference between experiments and sampling, last unit, or the last week, we mostly talked about sampling, okay? And then surveying or whatever to make sure we're getting valid opinions. Experiments are different. In experiments, we assign treatments. And when we talk about those treatments, that essentially is we are creating two or three or four groups that we compare the groups to each other, okay? So when we have an experiment, we have experimental units, and this is just, again, we have to do a lot of vocabulary at the beginning. The experimental units are whatever received the treatments. All right, and then the treatments are how we manipulate. And these are specific. We'll talk about that when we get to an example here, okay? The explanatory variable is kind of like the umbrella over the treatments. And here's what I mean by that. Do you guys remember when I did the Nate and AJ experiment where I gave you guys the names in one order and the other class got the names in the other order? Okay? If that's the case, the two treatments were Nate first, then AJ. That was one treatment. And then the other treatment was AJ first, then Nate. And the explanatory variable would have been the name order. You guys see what I mean now by the umbrella over the treatments? So the treatments are the different orders. Okay? All right. Your response variable is the measured variable. It's what you measure at the end of the experiment. All right, now, confounding is kind of like the bias of experiments, okay? And what it is an outside variable influences both the explanatory and response variable. You guys remember the shark attacks and ice cream sales, that they're both have high correlation? Okay. What did we say was the variable that messed that up? What made it look like high ice cream sales increased the risk of shark attack?
Because when it's hotter out, people want ice cream.
Yeah. So to describe this confounding, the weather warm weather was the confounding variable, yeah? Okay. So you need to describe the relationship to both the explanatory and the response. So in other words, you couldn't just say people swim more in the summertime. That wouldn't be enough. You would have to say people eat more ice cream in the summer. And swim in the ocean more in the summer. So you're connecting the summer to both variables. Okay, so you kind of have to say it explains the increase, it explains both things changing at the same time. Is everybody with me so far? And everything we do when we design an experiment is to do our best to eliminate confounding. Okay? Now, let you guys read this real quick and then we'll... Okay, so was this an experiment? Okay, what is the explanatory variable in this setting? Yeah, like how often teenagers are eating with their family, yeah? And was the different, so to decide, is this an observational study or an experiment, I need to decide, was eating dinner with the family assigned to the kids, or was it just kind of, it happened organically and they watched what happened? So, was it assigned? Like, hey, you have to eat with your family 5 times this week. You have to eat with your family 3 times this week. You have to eat with your family 7 times this week. Do you guys see what I'm saying? Was that assigned to the kids? No. So this is an observational study, and I know this because the dinner habits weren't assigned. And we can say, okay, then that explanatory variable, like we said a few seconds ago, is essentially the dinner. I'm going to call it the dinner habits. What's the response variable?
Grades.
I'm sorry?
Performance in school.
Academic performance. Specifically, they say grades. Okay. All right, now, are you guys comfortable saying that then eating dinner with parents causes an increase in grades? No?
Does it say anything about if you eat dinner, then it will increase?
Well,
It improves, yeah, never mind.
no, it said that for those who did,
Yeah.
they had higher grades than those who didn't. on the whole, right? Not like, and again, we never are talking about individuals here. We're looking for overall trends. Okay, so so essentially, here's what we need in order to conclude cause and effect. A correlation. That's what this is describing. Correlation is not cause and effect, just like ice cream doesn't cause shark attacks. Yeah. Okay. So because this is just an observational study without treatments assigned, we can't rule out any confounding variables. Can you guys give me an example of, in this instance, a confounding variable? So we would be looking for something that would be associated with having dinner with your parents and grades.
Time spent at home.
The amount of time spent at home? Sure. You guys, think back to the last conversation you had with your parents in the past week. What's the starter of that conversation most of the time?
How was school?
How was school? How many of you have conversations with your parents about school? Do you guys see what I'm saying? Okay, so what's the confounding variable? More time with your parents equals more time for them to inquire about school. Does it have anything to do with eating? Do you guys see what I'm saying there? Okay, so okay. In my response, you guys, talking about school and spending more time with them, with parents. I've mentioned how it ties to the eating dinner, and I've mentioned how it ties to better grades. So when you talk about confounding, it needs to tie to both variables. And the number one mistake I get from students is they say kids talk to their parents about school over dinner and not talking about how that makes them different from the group that's not. Is everybody good? Okay. So here's what we do with an experiment. Every experiment has 3 qualities that we need to have, okay? They are control, randomness, and replication. Okay, so here's control means preventing known confounding variables. Random means we use chance to assign treatments. Replication means use treatment groups that are large enough that differences won't be by chance alone. Okay. Okay, so let's talk about this in a bigger picture. Okay, so let's go back to the study up above, okay, and say, all right, we're worried about confounding, okay? Is everybody with me? All right, so first of all, if I was going to rework this study so that it was an experiment, what I would want to do is make sure that I design that experiment in such a way that I'm accounting for some variables that I'd be concerned about, okay? What are some variables that might be confounding in this setting besides just like the amount of time that kids spend with their parents?
Whether kids do sports or not.
Sure, because I would imagine knowing your guys' schedules that's probably one of the number one factors that influences whether you have dinner with your folks or not, right? Also, kids who have sports have somebody else, usually that's checking in on their grades as well as their guardians, right? Because coaches pay attention to grades a little bit, and certainly they know if you're on the ineligible list, right? Okay. What else?
Parents care about your school.
How much your parents care about your schooling? Sure. What about just like the overall achievement of kids, right? There are some kids that are just not as strong of students as others, right? Is everybody with me? Okay, so what we might do is we might say, hey, in this study, we're going to assign eating times with the families. Okay, so we're actually going to say, for the next 3 weeks, you're eating on your own and you're not. You guys get what I'm saying? But what we might do is say we might only use, say, an AP class so that we know that we have high-performing students. Do you guys get? Or we might only use 5th and 6th grade students because they're all included all the time. Do you guys get what I'm saying here? Okay. That's control. That's something we know about in advance and we try to control for it. Okay? We might say, we're going to provide the same type of food to both groups so that, one group isn't eating pizza while the other one's eating this like super well-balanced meal, right? Everybody good? Okay. Then what we're going to do is it possible there are variables that are confounding that we don't know about? Like if I just said this side of the room and this side of the room, that could be problematic as well. In one way or another. So what I'm going to do is I'm going to throw all your names in a hat and I'm going to draw one to go in this group and one to go in this group, then one to go in this group, and so on and so forth. I'm going to use chance to decide who's in what treatment group so that any other problems aren't there. Okay? So with these two things, the goal is to make the groups as similar as possible before the treatments. You want, before the experiment, your treatment groups to have a level playing field. So, if your two groups are the same before the treatments, you assign the treatments and then you see differences, we're pretty comfortable saying that the treatments caused that difference. Okay? So, the goal of the setup of the experiment is to make the groups like this before, so that the only difference between the groups is the treatments. That way, if the groups are different, the treatments are what caused it. Everybody good? Okay, so if we have a well-designed experiment, we can, so I said in the last unit, in unit 2, just because we have a correlation does not mean we can conclude cause and effect, right? If you have a really strong correlation in a well-designed experiment, you can, but it's the fact that you have this well-designed experiment. That's what allows us to conclude cause and effects. And the why is because the treatment groups are the same. You give them the treatments and then they're not the same. The treatments are what cause the difference. Okay? So that cause and effect can go from when groups start the same, they go through the treatments, and then they're not the same. That's when we can conclude cause and effect. So everything we're going to talk about in terms of coming up with the design for our experiment is going to be all about start the same, have the treatments not the same. So everything we do to design is to make sure they're starting the same. Okay. So a lot of these terms I think you guys have heard in science classes and stuff like that. We're just going to kind of whiz through them, but they're all things that we consider no matter what our experimental design is. Okay, do we need a control group? You guys, sometimes it's not possible to have a control group. Okay? Now, we need comparison groups. And we'd like a control group. Like, we should have one if we can. What is a control group? It's a group that didn't receive a treatment. But sometimes that's impossible. For example, if I wanted to test a new statistics program to teach you guys statistics, I'm teaching you statistics no matter what. I can't have a control group for a group. Like I could have some group that uses the program, some that uses the current program that I'm using, like in terms of the way I think through stuff, right? All right. But both groups would still be receiving statistics instruction, right? There would be no control group there. Okay, what is the placebo effect? This is not me asking what is a placebo.
Placebo effect would be like you think that something does in fact change the outcome, but it really doesn't.
Any treatment can see a change, regardless of what that treatment is. So what we do is we give what we call it, when we give somebody a placebo, the idea is which is kind of like a control group, we give somebody a fake treatment. Like sometimes we call it like a sugar pill if it's in pill form. It would be like someone getting an injection of saline instead of like a liquid form of something, right? So it's just, if people believe they're being treated, they're going to improve regardless of what that treatment is. So how do you decide if the treatment works if both groups improve? Well, what happens is both groups improve, the placebo group doesn't improve the same way as the treatment group, but both would show some sort of change. You guys get what I'm saying there? Okay? All right. Now, what do you guys know about blinding? Anything?
The group knows what happens.
Okay, so I want you guys to think of like, in an experiment, there's two sides to the experiment. There's the subjects that are being experimented on, okay? Or the experimental units, and then there's the person doing the experimenting, okay? So in a single blind, one side does not know the treatments. Typically, the subjects. In a double blind, both sides do not know the treatment. And you hear these a lot in medical studies, specifically in drug trials, stuff like that. And the idea being, if the doctor knows whether or not somebody's getting the real treatment versus the placebo, there might be changes in their attitude while they're administering the drug. So like double-blinded is the best thing. Now, blinding is not always possible. Okay? Because there's some things that there's no way for you not to know which treatment you're receiving. Everybody okay? The other thing I want you guys to recognize is that experiments don't just happen on people, right? Like, I could be testing a new washing machine. Think about, like, Whirlpool is developing a new machine, and so they want to compare, is it as good as the other one? They might randomly assign different loads of laundry to the two machines and have somebody rate them, and that would be an experiment still. Okay, so I don't want you guys to think that experiments only apply to, like, people. All right. All right, in this case, we're looking at different ways to lose weight. Yeah? Okay, so in this case, I have 90 volunteers. So for those 90 volunteers, we have how many treatments? 3. One is the control group that's just getting the brochure, right? One is low carb. One is low fat. Everybody good? These are our 3 different treatment groups. Great. So in advance, what are some things we might want to control about these different groups? Go ahead.
Starting weight and height.
Okay, so I wouldn't call those controls because they exist. Like we don't control what they are, but they are definitely starting weight and height is definitely something to think through. And the way we might control for that is, instead of measuring at the end, maybe our response variable shouldn't be their weight, but rather their change in weight. That controls for their current weight, right? And maybe what we do in terms of height is certainly taller people, or we would expect them to weigh more, right? So we might say, hey, I want to make sure all three treatment groups have some tall people, some medium height people, some shorties.
Could we use like BMI if we want to factor in height?
So we can't control for BMI, but that might be another thing that we would use too. That might also be what we measure instead. Like if you use BMI, though, certainly BMI is coming under attack quite a bit in terms of, is it a good measurement of fitness? What else might affect if we decide to use weight loss as our response variable? What are some other things that might affect how much weight somebody loses?
Age and gender.
Age and gender, okay. What else?
How strictly they actually stick to the program?
Okay. How about this? Don't you think all three programs should have similar diets in terms of, not diets, but caloric intake? Okay, so we might prescribe X amount of calories per pound. And that would help account for like the bigger height and weight. Certainly what it takes for Mr. Peters and what it takes for me. We can't eat the same volume, right? Or if we did, he would be a skinny mini by the end. Or vice versa. I would be not skinny, right? What else influences weight loss? That we would want to make sure that all the volunteers are doing the same thing.
How much you're moving around each day.
Exercise. For sure. So when we talk about these different things, the control is we would maybe prescribe the same amount of exercise for each person. So we wouldn't necessarily need to say no exercise, but we might need to think that through. Yeah.
For exercise, would we also want to look at like what they do for a living? Because like someone who works construction is probably going to lose more weight than someone who works in an office.
You say that, I think it would go the other way around. You can't control what they do for work, but you can consider it, right? I think someone in an office, like someone in construction, is already moving around a lot. That I think they would actually probably not change that much because they're still lifting the heavy stuff and building that kind of body mass or whatever. But maybe not. I could be wrong. Okay. Are we getting an idea for control? Okay. So then we have random.
For lifestyle and control, we kind of just weed out certain people.
No, you can't weed out because you have your 90 volunteers. That's who you have. Again, for the stuff you can't for the stuff that's hard to control for, what you do is you try to ensure that, okay, so let's say of the volunteers, 10 of them are all construction workers, okay? What you might want to do then is put like 3 construction workers in the first group, 3 construction workers in the second, 3 or 4 in the third. So you try to make sure that they're all equally represented in the treatment groups, so then any impact that their job might have would impact all 3 groups. So remember, our goal is not to make it go away, it's to make it similar for each group. Does that make sense? Okay. For random, we need to use chance, which I'm going to say an RNG or names out of a hat. To assign the treatments.
Could this be a time to use like a stratified one? That way we can separate the construction workers from.
It's called something different. So stratified applies to selection, like how are you selecting your sample. That probably won't get to that today, probably tomorrow. But it has a different name, but it's a similar idea. Okay. And then for the replication, we're going to say 90 volunteers is a good size. that if we see differences in groups of 30, that's probably going to be enough, is going to be telling. All right. So let's leave it there. Tomorrow we'll talk about doing the random assignment.